project is using AI to remove background noise. So the goal of our project is to make meetings in noisy environments more bearable. So say you are making a call on a noisy train. You don't want the chatter getting into your call. Or say if you're in a Zoom meeting at home, you don't want your family talking a lot and letting your meeting hear your family.
So the motivation for our project is because a lot of us have been annoyed by background noise. So for example, Thomas, please mute yourself.
Oh, sorry.
Like, as you can see, that was pretty annoying, and Thomas probably thought that was a little bit embarrassing for himself too. And if that continues on for quite a lot of time, then it'll be distracting and it'll hurt the productivity in general.
So the current state of the art to cancel voice is these examples that you can see on screen, which is such as Zoom, this AI that cancels human voice, and Crisp. So all of them have like flaws and problems. Like Zoom, it just barely works. This AI, it only cancels human voice, and it doesn't cancel static noises such as like a drone of an engine or something. And it replaces the human voice that gets canceled with a lot of extra static. And Crisp, it only cancels static noise, and it doesn't work very well either. There'll be like weird noises, and the voice will get changed a little, which sometimes can be more distracting than the noise itself.
So the solution, the steps to our solution is that because of course we can't immediately code an AI to solve this problem, so we'll take small steps. So the first step is to just be able to tell whether there is background noise or not. The second step would be to filter out classic background noises, which is like constant hums, like engine sounds, AC, and like TV static, or like just kind of static noises. And then number three, we'll try to figure out try to filter out dynamic background noises, which is like things that have various tones, like piano and other musical instruments. And our final product will be able to filter out all of those and other human voices that aren't the person that we are trying to, that the target person who is trying to speak.
So we have two proof of concepts, which is Crisp.ai and the AI that focuses on human voice, and we prepared some samples. So for instance, this is the AI that focuses on human voice. So the first sample is two people talking over each other, and it's really hard to understand what they're saying.
It is surprising how soon the eye
Computer sound
becomes accustomed to
So as you can see, it's pretty hard to see what the man's saying, but if you just say a short phrase to the AI that lets it recognize your voice like this.
A man said to the universe, "Sir, I exist."
Then it can filter out the other person and make it much easier to understand what the man's saying.
There could be little art in this last and final round.
It's not perfect, but you can see that there's a much better improvement than what it was before. But we hope that our AI can get closer to the ground truth, which is this.
There could be little art in this last and final round.
So we also have a sample from the Crisp.ai website of a coffee machine in the background. So.
And with the banks, we'll take a step back and use our own capital instead.
As you can see, the coffee machine is quite distracting, and if we turn on the software, it cancels out the coffee pretty well, but it's also a bit wonky with a bit more high-pitched speech.
To buy the remaining shares. So Linda, please get started on that and prepare the financial records as soon as possible.
So yeah, we hope that we can improve on the wonkiness as well.
So our goals for the future are to train an AI using this data set, the Interspeech 2020 Deep Noise Suppression Challenge, which is an open source clean speech and noise data set for training noise suppression models. This, the Microsoft has DNS challenge, is a GitHub thing that has the scripts and models and required files for us to train AI on it. So we can also use that. We want to build some specific modules with the AI. So first, a voice feature extraction, which would be to split a sound wave into multiple smaller waves that are each like 1 thing that represents the entire thing. And then to build that a step further, turn it in such that each sound wave is one speaker that adds up to the full wave of everyone talking. And then to be able to find a specific user talking in a mixed noise and recognize that this is this user. And then just classic white noise filtering, such as a blender or air conditioning unit. And then our final goal would be to recognize and cancel everything that is not our target user.
Yeah, so that's basically our project.
Chong, you available? How's your voice?
Yes.
Great.
Yes. So
Okay.
hopefully this is better
Advisor
now.
time.
Okay. Yeah. Thanks. So yeah, thanks, Alex, Mel, and Thomas. Yeah. So just adding to your presentation. So the wider what I see is this is a kind of a project where like you guys really get excited and get involved. This is something you are experiencing a lot of time in your life, and actually that's something you can tackle from on your own. So I think definitely this is a very interesting topic and worth to pursue it. And there's enough challenges for you to work on, and also I think there are a lot of innovations can come out of this. So that's I would say, yeah, that's my comments for the first part. The second part, I think you guys have done guys have done a lot of work regarding exploring the available materials, including the state of art and the existing solutions and the limitations, and also possible resources for build up on existing work. And the last part, I think you have a good, a reasonable proposal. Of course, this is still very unclear at the beginning, but I think you have some idea and a path to explore. So overall, I think this is quite interesting. Hope you guys can continue and make some good result out of this. Yeah, so George, please feel free to ask them questions. Yeah.
I noticed that you said that you would filter out all other voices other than the target speaker. So what if, let's say there were two people who were sharing the same laptop and wanted to speak at the same time,
We could
Well,
have,
then-
wanted to speak in the same presentation together?
Well,
we
then
could have.
complete that.
Oh wait, Miles, you just say it. You can say it.
Okay, so well, as we said before, we have multiple modules, and you will just have to turn that one off and only use the other ones, such as dynamic and white noise filters.
So it's kind of like you have a bunch of users, and you can turn each user like on and off. So you have to like, each user has to give a little section so the AI can recognize their voice, and then you can basically, since we can separate out the voices, then we can choose which ones to keep.
Got it, thank you.
So if you are able to separate, basically recognize the voice print, then why would you need the intermediate step? Why don't you directly keep the voices you need?
Because so background noise can sometimes interfere with the voice like separation AI process.
I see. So basically, it's some internal AI implementation, the modeling part that require you to do that, right?
Yeah.
Also, it would be an easier first step for us to try.
Got it. Yeah, sounds good.
Hey, can you guys talk about? I don't know if you. It's about a great presentation, and I always love to see demos. But how do you guys envision this turning into a product? And have you guys talked about potential business model as well?
Yeah. So for example, if we can make this work properly, I feel like virtual meetings in the future will probably have a large part in our lives, because some people might not be able to make it to some places to have an actual meeting. And also, for example, we can use this product, we can like collaborate with Zoom or any other virtual like meeting softwares.
Or like we can also consider like charging a monthly subscription, or yeah.
Thank you.
Which specific filtering algorithms have you looked at?
Well, we looked at that one that Thomas showed, which was a PyTorch implementation.
Okay, so one based on deep neural networks.
Yeah.
In that case, like, do you have any? So this might be a rough question. But do you have any like advantages over like state of the art? Like, do you have any advantages over CRISP AI?
We have my mom, and she's big brain.
All right, sounds good.
There's some like downsides to the CRISP. It's like there's a little bit of interference. For example, the coffee machine and the voice. It changes the voice a little bit, and in some other cases, it might even completely like ruin the model.
Yeah, I'm asking like, is there a way that you can ensure that your model doesn't do the same thing?
Not really, because we haven't actually made a model yet.
Yeah, sounds good.
I have a question. Like earlier you said how like there were two things, like one that could sort of turn human voices into static and one that could remove static noise but not remove human noise, right? So what if you just combine the two of them? Wouldn't that remove all noise?
Yeah, that's what we're doing.
That's what we want to do, but we can't just steal the technology.
But like none, and also those things aren't like they're not perfect. So we want to try to make a better model.
I see.